Welcome back to Math 109, Plain Trigonometry. In this video, we're going to take a look at some compound trigonometric functions, including some inverse functions, and look at ways that we can just write them as an algebraic function. So we're going to look at a couple of examples here. The first one is the sine of the inverse tangent of u. Now we're actually going to be able to write this without having any trig symbols in our final answer. So the way we're going to do it is to first let theta equal the inverse tangent of u, which would mean u is equal to the tangent of theta. So in doing that, this function becomes sine of theta. So now you might be thinking we want to know what theta is right away, but we don't necessarily need to know that. We can instead draw a triangle . And we know that tangent is opposite over adjacent. So we're going to let theta be down here. So we have opposite over adjacent. We can use those two sides to find the hypotenuse. C squared equals a squared plus b squared. So we have u squared plus 1 squared, take the square root. So the hypotenuse is of length u squared plus 1. And then we know that the sine is opposite over hypotenuse. So the sine of theta here is u over the square root of u squared plus 1. And then the book insists on going on to rationalize that denominator. We're not going to worry about that too much in here, but for the sake of completeness, I'll go ahead and do it. In this case, we can just multiply both the numerator and denominator by the square root of u squared plus 1, which will give me u square root of u squared plus 1 over u squared plus 1. So that's one type of problem you're likely to see on this. Other one is actually a little bit easier. Give you something like cosine of 2 times the inverse sine of u. So again, we're going to use the trick we started the last problem with. We're going to let theta equal the inverse sine of u, which means the sine of theta is equal to u. So making the substitution in this problem, we get cosine of 2 theta. Well, we know a trig identity that says that that's equal to 1 minus 2 times the sine squared of theta. But we know the sine of theta is u. So we get 1 minus 2u squared for our final answer. So that's a couple of examples of how we'll deal with inverse trig functions in combination with regular trig functions, turn things into algebraic statements. So that'll do it for section 6.1. In the next set of videos, we're going to take a look at how to solve trigonometric equations.